Hello, friends. I believe it's a good evening to all of you. I'm joining you from the beautiful morning here in Brisbane, Australia. My name is Gurian, and I'm Director of the Bachelor of Science here at the University of Queensland. Just before we get started, I'd just like to introduce a couple of other people joining and supporting me on this webinar, but I do want to pay a really big welcome to all of you who are joining us today. We're joined by Grace Lee. Grace is our Faculty of Science International Manager. She takes care of all of our international students from all around the world that come and study science with us here at the University of Queensland. We're also joined by a representative, Alexis, from the National Society of High School Scholars. So thank you very much for making us look so good on our webinar today. But everyone, welcome again, and thank you for joining us. I'll introduce myself very briefly. My name is Gurian, and you can probably tell that I am not originally from Australia. I am from Singapore, but I've spent the last 14 years of my life here in Brisbane, Australia. And I actually, like many of you thinking about an international education, left Singapore to pursue an international education. So I came to Australia to study. I also did a Bachelor of Science. I really loved animals. And so I studied zoology as a major in my Bachelor of Science degree, moved on to an honors research year, a PhD, and one thing led to another. And now I get to contribute back to science by I guess leading the many students that that study a science degree here at the university. And you're going to explore a little bit more about this degree with us very, very shortly. Now, I will just start off with thinking a little bit more about what scientists are driven by. And for many of us, we're scientists because we're curious people. We're driven by curiosity. So, I'm very sure many of you wake up in the morning asking yourselves what the significance of the threshold frequency when incident light with a range of frequencies shines on a metal. Oh, I'm sure many of you wake up thinking about these questions, right? What's the atom economy for the fermentation of glucose to bioethanol? How do errors during DNA replication lead to point and frame shift mutations? Now, these are all questions that scientists ask. And if any of you find them slightly familiar, then there is a very, very good chance you are in your final year of studying science in high school, because these are typical exam questions that you might find in physics, chemistry, and biology, certainly for here in the Australian syllabus and certainly in the International Baccalaureate syllabus. So these are already questions that we answer at high school. What then do we do at university? Well, the scientists at university are driven not just by curiosity, but also our commitment to our community. So in other words, here at university is when we start to take the science that we've learned, we learn even more about it, but then start thinking about ways in which the science can benefit people and the environment. So we start asking questions like how we built the next generation of imaging technology. Again, thinking about what we have a solid foundation from science that can allow us and enable us to answer these sorts of big questions. We ask things like how we optimize the production of alternate energy sources. We ask things like using genetic technology to treat diseases. So at university, science gets transformed and we take what we've learned, we learn even more about them, and through research and through experiences, we start finding solutions for our community. So that underpins the framework across all of the science degrees offered at the university. So what I didn't tell you is what I teach. So you'll probably struggle to find me in this photograph, but I teach second year ecology. That's the main course that I teach, and these are my second year ecologists out in the field on campus. We're really lucky to have such an amazing and large campus that includes a nice little nature strip for students to do some field work in. But across all of our undergraduate degrees that you can see here, today's focus really is on the generalist degrees. So these include the Bachelor of Advanced Science Honors and the Bachelor of Science. And within this generalist degree, you get to go on science adventures. Now, you cannot go on all of them, but this is literally the A to Z of science. And we are Australia's most comprehensive science university, offering 40 discrete scientific disciplines. So what are these adventures? You're probably familiar with the concept of majoring in something when you're at university. That's a very similar thing we have here at the University of Queensland. You can embark on a major, which also implies there's the option for you to minor in something else. But we also have something called the extended major for those that really, really, really love one particular discipline. So I'm going to show you how it works just very, very quickly and hopefully give you a glimpse of what studying at the university is going to look a little bit like. At UQ, we're spread across 2 semesters in the calendar year. Semester 1 commences at the end of February, and you'll sit your final exams by the first week of June. Then you go for a short winter break, and now you're probably a bit puzzled as to why we have winter in June. Well, that's because we're on the other side of the world and in the southern hemisphere where the seasonalities are flipped around. So we go for a bit of a winter break in June, July, and in semester 2, we commence semester 2 at the end of July, and you'll sit your final exams by the first week of November. And then that leaves you a relatively long summer break. So November, December, January, February is a nice long summer break. Many of our international students might choose to go back home, perhaps for Christmas, or they might stay in Australia and undertake part-time work or even enroll in courses across our summer semester. But most students will confine themselves towards studying in our semester 1 and semester 2 main semesters. The generalist undergraduate degree will take you 3 years to complete. And you can see here some boxes attached to each semester, 4 in total per semester. Each box represents an amount of work that you will do, and we call that a course. So at UQ, in a full-time study load is 4 courses per semester. So you're quite right, and if you've done the math, you will complete 24 courses of study to complete your degree. Now, in the science degree, 2 first-year courses are compulsory. Every scientist cannot run away from 2 important foundations to science, and you can probably guess them by now: statistics and philosophy. So these 2 are our core courses that all science students must complete, preferably in their first year. Then you'll now see gold boxes that I've overlaid into this model here. And you'll notice a particular distribution across the years. There's 1 gold box in the first year, 3 in your second year, and 4 in your third year. And this is the ratio of courses that count towards your major. All majors in the science degree have 1 first-year course, 3 second-year courses, and 4 third-year courses. And you're quite right in that, of course, you're thinking of introductory level, intermediate level, and then advanced level courses as you move from level 1, 2, and 3. In preparation for the major, to make sure that you are really well prepared, some majors require you to complete prerequisite courses. And you'll see here, I've added 2 green boxes in, because they are courses that you must do in order to perform well in your intermediate and advanced level courses, but they don't necessarily count towards the major. So this gives you a bit of an overview of a student that wants to do a major. Now you'll notice, though, that there are still a lot of blank boxes. That's the beauty of a generalist degree, because you choose your own adventure. Now you realize that you can mix and match this major with a variety of other plans. You could do 2 majors. You could do a major or a minor. You could do a major and 2 minors. How you choose to design your degree is completely up to you. And with the breadth of disciplines offered at our university, the permutations are quite endless. Now, here's another example of what a student could do. Some students really, really like one particular discipline and choose to declare it instead of a major, but instead of a major, they do it as an extended major. Notice now, what hasn't changed is that there's still green boxes. So there's still first-year courses that support the level 2 and level 3 courses. But at level 2 and level 3, you'll notice now that there are more courses that the student needs to do. In this case, 5 at the second year and 6 in the third year. Now, an extended major also implies now that there are fewer blank boxes. So there are fewer electives that you have room for. So again, it's up to you how you want to design your degree. Many students also consider another option, and that is instead of an extended major or a major, they combine their major with a minor. Now you'll notice here that a minor is represented by a blue box and that there are only 4 of these blue boxes. And that's because a minor is simply the completion of 4 courses. Now, if you're very observant, which you are because you're a budding scientist yourself, you'll notice that in this situation in the bottom right, that it looks like there's only 1 green box, only 1 prerequisite. That's because this student has been very, very clever in choosing a minor, which already includes a prerequisite that they had to do for the major in the first place. So you can actually be quite strategic, and you're quite right. A second major is also but a second minor is also possible, shown here in the light blue. So how you mix and match all of these different plans together is really up to you. I'm here when you arrive to give you that guidance and walk you through your strategies and come up with a study plan for you. But now is a good time to just think about what those adventures might look like. And I'm coming back now to the broad suite of adventures that we have available in the science degree. And I'm going to give you 3 very short stories to show you how you can mix and match these. I'd like to introduce you to my grandparents, both of whom are still alive. And, well, it comes as no surprise that I'm from a culture that success is measured in a very narrow number of occupations. So growing up, it was not uncommon to hear from my grandparents that I have to become a doctor. Well, I tell them frequently I am a doctor, but unfortunately not the type of doctor they wanted me to be. But many of you who are interested also in pursuing a medical career or becoming a medical practitioner, I couldn't be happier for you. Australia needs more medical practitioners than ever before, particularly in our regional and remote regions. But for many students, the rite of passage to becoming a medical practitioner is to first start in an undergraduate science degree, and they would major, very unsurprisingly, in biomedical science. But alongside that major, they might want to consider whether or not there is an avenue related to biomedical science that they might like to mix and match their degree with. And then they realize that half the problem is solved by preventing people from getting sick in the first place, with over 17% of infectious diseases being actually vectored by an invertebrate. You're probably most familiar with mosquitoes. So here's an example of what I call a spicy combination or spicy combo. That's a thing here in Queensland. And so here's an example of a spicy combo. And your spicy combo might be taking something like biomedical science and combining it with another discipline like entomology, the study of insects. These two skill sets combined together allow you then to occupy a very, very unique employability niche in the workplace. You know, there are very, very few medical entomologists out there. Here's another story to help your creative juices flow. Most of the fabric that we wear, the natural component comes from the cotton plant. Cotton is, of course, not only consumed by humans, and there are many other pests that like to attack the cotton plant. The only problem with this is, of course, that by the time you realize you have a pest infestation on your cotton crop, it's often too late. So it's not uncommon for growers to want to bombard their crop with copious amounts of insecticide. And the problem with insecticide is the sustainable use of insecticides. Many insects develop resistance very quickly, and there are also issues with the presence of insecticides in the environment. Hopefully, this is not an unfamiliar story to you, but a fascinating one nonetheless. In this bottom right image, you're looking at a scanning electron micrograph. That implies that you're looking at something incredibly tiny. You'll notice that there are these diamond-shaped crystals that have been colored purple. These diamond-shaped crystals are toxins produced by a bacterium. And what's really cool is what happens when a caterpillar, unfortunately, ingests one of these toxins. These crystals bind to receptors in the gut of the caterpillar, and what happens is that it causes the gut of the caterpillar to perforate, meaning to say that all of the pores that line the gut now relax and they now open. Now, what you expect to happen when you eat, when you consume food, is that as your gut breaks it down, all of the nutrients should go from your gut into your bloodstream. But if all of the pores are now relaxed, the reverse happens and the blood now pours into the gut. And that's an unfortunate consequence for these caterpillars. So when they consume these crystals, they basically drown in their own blood. And some of you are probably a little bit grossed out by now, but this is also very fascinating because these crystals are naturally occurring crystals, which means that we can combat pests using very natural organic ways that ultimately allow us to alleviate the use of insecticide. Even better, we've discovered the gene that makes this crystal, and almost all of the cotton that we grow in Australia has had this gene inserted into the cotton. And so, if you're still on the fence about consuming genetically modified organisms, I can promise you that you're probably wearing one. So now a lot of the cotton will naturally express these toxins in their leaves, and as soon as caterpillars consume them, they die, right? So here's another example where multiple disciplines that come together give you the edge. Here's another spicy combo. You could major in something like genetics, but remember that genetics is only the toolkit. You need to find a context to use these tools in, perhaps in solving challenges related to agronomy and plant science. My third and final story for you is perhaps something a little bit more familiar. Many of you might remember this scene, the uncomfortable old school way of COVID testing, where a nasal swab, fairly long nasal swab, would have to be inserted through your nasal passage to reach the back of your throat, right? It's an extremely uncomfortable experience. But the story is not about COVID testing, but rather all of the hospital-grade equipment that you see in this one photo alone, from the head cap to the eyepiece, to the face mask, to the lab gown, to the lab gloves, to the nasal swab, right? You want the assurance that all of these equipment are sterile. Yes, you want to make sure that they are clean and that they are free of bacteria. And so you want to be able to test that they are in fact sterile, that they are free of contamination. And we can do that with this very simple test. You can see here two test tubes that have been inverted, and this beautiful magical liquid held within the test tube seems to be defying gravity, right? It seems like it's not flowing down. And that's because this liquid has turned into a gel. It's turned into a semi-solid. And the reason why it's turned into a semi-solid is in the presence of contamination. This occurs. So this magical liquid, this sterility testing that we do here has saved millions and millions of lives. Unfortunately, we cannot make this liquid. This liquid needs to be harvested, and it is harvested from the blood of horseshoe crabs. And you can see here that blue blood, it gets purified into this clear liquid, and then it's used in sterility testing. Of course, I'm not here to make you feel sad about this animal, but rather to also share with you that there are a good number of tomorrow's drugs and vaccines that have derived from the ocean. They are a wonderful treasure trove of lots of chemical compounds that are going to benefit humans and human health dramatically. And there are 12 currently in clinical trials, including ones that treat Alzheimer's disease and lung cancer, that come from organisms in the ocean. And so here's another example of where multiple disciplines, when combined together, give you a really unique, spicy combo. Here you have marine biology, but if you want to also be involved in drug design and discovery, we also have things like biochemistry and molecular biology, or even biophysics, which is interested in the movement of molecules across the cell membrane. That's biophysics. So I hope that these short stories have given you some idea of the flexibility given to our science students that allow them to really think about what workplace niche they might like to have in the future. And in doing so, allow them to mix and match different skill sets so they offer the workplace something truly unique. But wait, there's more, because what's better than a spicy combo? Spicy Combo Plus. Spicy Combo Plus allows our science students to do this. First, they pick their main course, which is, of course, their major. But we also allow our students to add dessert in the shape and form of a non-science minor. So that is absolutely possible as well. And in fact, most of the students in the science degree that have a combination of majors and minors, oftentimes one of those minors will be not a science minors. And I encourage our students to be interdisciplinary, if not multidisciplinary. So you can see here a wide range of languages, even things like sport studies, even things like criminology, even things like economics are available as minors that science students can do. But wait, there's more, because we also have double spicy combos. Why have one when you can have two? And this takes the shape and form. Up until this point in time, I've explained to you our single degree, the Bachelor of Science, but we can also allow our students to pair the science degree with another. And here at UQ, we call these dual degrees. So you could absolutely take a Bachelor of Science and concurrently do another degree. And the science degree plays well with others. There are 14 partner programs with our science degree. And in a weird way, the way it works is this. A single degree would have taken you 3 years to complete. A double degree or a dual degree allows you to give up all of your electives so that you can complete 2 degrees ultimately in a shorter amount of time than had you done both of them separately. So the science degree on its own is 3 years. The arts degree, for example, on its own is also 3 years. But when you do them together, it'll take you only 4 years to get both degrees. Of course, that comes with a trade-off, because you'll see in this study plan, for example, that in the arts degree, all the squares are gold, meaning to say all the squares are courses that count towards a major. So in the arts degree, all students must do 2 majors, whereas in the science degree, you only need to do 1 major. So it's a bit of a trade-off to think about. Okay. Finally, before we take your questions, many of you have probably heard of this idea of an honors year, right? Or an honors degree. At UQ, that takes the shape and form of research. And for our science students, that research is including experimental research, field-based research, but in some cases, particularly for those that lean on a social science approach, might include interaction with people as part of their research. So the honors research year is designed for students who are planning to have an experience of professional level research because they spend the full year working on a research topic. Many of the students that complete an honors year do go on to publish their work in peer-reviewed journals. And a number of them then seriously consider whether or not they'd like to continue doing research. And then that at UQ at least takes the shape and form of a doctoral program or a PhD. So after the 3 years of a Bachelor of Science, a student is expected to find an academic supervisor, meet the GPA requirement, and then apply into the honors program. And that gives you a nutshell of what the honors year might look like, but noting that it is an independent year that you apply into after completion of your undergraduate Bachelor of Science degree. Okay, so I hope I gave you a nice overview of the science degree, and hopefully you have maybe a little bit excited about just the ability to mix and match different disciplines based on your interests. Now I'd like to welcome any of you with questions. Grace is also available in case there are questions I'm unable to take care of. And I welcome you to ask your questions either via chat, or at the bottom of your screen, you'll see a little speech bubble icon with a question mark in it, which allows you to also ask questions anonymously. I'll do my best to get through as many of them as possible, and some of them we will type answers to, and then it'll appear in the answered sort of panel. Okay. So I'm going to start with some of the questions already there, but if you've got further questions, feel free to start asking. The first question is about average class sizes. Now, this really depends on the discipline that you are in. I explained those first year foundational type courses. Unsurprisingly, at first year, many students do the same course. So the stats courses, if you have a physics slant, the physics first year courses, or the first year chemistry courses, or the first year biology courses. So many students study the first year courses together. So first year courses can be as large as 1,200 students in the cohort, but can be as small as 300 or 400 students. So that's at first year. Moving to the second and third year is when it then starts to shrink quite considerably. And for example, those pursuing marine biology might be in a cohort of 100. Those pursuing genetics might be in a cohort of 50. So it really does depend on the cohort size. The question that follows after that is whether or not we have a chemistry major. We absolutely have a chemistry major. And if you're interested in the cohort size of the chemistry major is probably about 30 to 40 per cohort. But in the courses that you do, remember, there might be students also doing biochemistry, or there might be students also doing biotechnology. So your cohort that are also majoring in chemistry might be 30 or 40, but in class, it might be 100. Okay, I hope that answered your question. The next question is whether or not we have a forensics program. That's a great question. We don't have a plan, meaning we don't have a major or we don't have a minor in forensics. But if you are interested in forensic science, there are a few things you need to think about, and that is the type of forensics you want to do, because you'll actually find that forensics in practice relies on subject matter experts, and perhaps some of the more popular crime-based shows from Hollywood are probably not a reliable barometer of what the career in forensics actually looks like. Because oftentimes there's a misconception that the person at the crime scene is a subject matter expert in all types of evidence. That's completely untrue, because when you collect all the evidence from a crime scene, they actually get processed by subject matter experts. So a microbiologist or a chemist, right? And so thinking about forensics and playing in that space, I would recommend something along the lines of majoring in chemistry or biochemistry or microbiology, but perhaps even considering a minor in criminology. That's what students absolutely can do. Great. Grace, there is a question about a student currently finished high school, but now in a community college. I don't know whether you wanted to type that response. Yeah, and there are a couple in the questions that are a bit more administrative that maybe I can let you handle. I'll just answer a few more first. There's a question about how broad environmental studies or zoology studies span in Queensland. So I'll just break this one down into two components. We do have environmental science, and then we do have zoology. Environmental science is interested in a weird way in the physics and chemistry of the environment, right? So there's geochemistry, there's bioinformatics. There are one or two courses that you could do that's policy related. So that's what environmental science is like at UQ. Now at zoology, now that's really about biology, right? So it's everything from all forms of animal life. And of course, you cannot run away from the basic taxonomy and being able to identify animals. But the zoology students are also encouraged to also combine that with animal behavior, animal physiology, and it's very, very important. And many of our zoologists forget that you're only a good zoologist if you are simultaneously a good botanist, right? So a lot of our zoology students, I encourage them to also do plant ID because the animals that you're going to be working with, or the animals that you might be taking care of in the future, eat plants. And if you cannot identify the plants to feed them, then that doesn't make you a very, very good zoologist. Okay, so that gives you an idea of environmental science and zoology at UQ in terms of the depth and breadth. Yeah, okay. Okay, good question. There's a very, very good question about inclusion at UQ. Could class sizes be smaller for students with accommodations, like working in a small group or surrounding? I'm so happy you asked this question because you are not alone and you are part of a very, very large and supportive community you will be part of a very, very large and supportive community at UQ. So I just want to unpack this a little bit. The first most important thing is that UQ does recognize that not everyone learns in the same way and that the learning environment is very, very crucial to your ability to operate effectively. All our students are eligible for special access plans, but you have to apply for them. Oftentimes, this comes with sitting down with one of our counselors, looking at your medical history and your requirements, and then coming up with some accommodations that all the course coordinators in every single course that you undertake need to agree to. So that's the first bit. The second bit is that you'll find that even though maybe I overwhelmed you by saying, wow, at first year there are 1,200 students, the 1,200 students don't see each other simultaneously, right? Because the largest lecture theater sits 400. So sometimes if you find being in a large crowd overwhelming, lectures, for example, are all recorded. So many students that would prefer not being there in person because it's uncomfortable for them might choose to watch a lecture online. When it comes to a in-person practical class or a tutorial or a workshop, those generally shrink in size. And a practical class, even though there might be 100 people doing the practical in a large lab at the same time, the construction of our labs is such that even though there are 100 people doing it simultaneously, you're actively only participating in a small pod of about 15 to 20 people, right? So that's the architecture of the lab space. Now, in the first year courses, particularly our first year stats and first year philosophy course, we have an amazing, amazing academic that has joined that team recently, who herself would prefer quiet environments to study. So she's actually championed for the quiet classroom. So in most of our first year courses, small scale tutorials have an option for a quiet based a sort of learning environment where the learning environment is in a venue where the tutor is trained so that there isn't that level of loud engagement, but rather we sit down and we work in small groups quietly on the problems, right? So there are lots of accommodations in that regard, but I would suggest that you shouldn't expect, you shouldn't expect that it'll be perfect. That's the nice challenge of being at a university. You really should ask for these things, and then we will do our best to accommodate you. Okay, great. So I hope that answered that question. Okay. That's a good question. How do I choose what school to attend when there are so many good ones? And I assume that good in your mind could include things like ranking or location, or disciplinary offerings. I guess I would say that this is a very, very personalized, a decision that you've got to make. And I've worked with students so frequently from all sorts of backgrounds that I think the one indicator of success at a university is the fit. And by that, I mean, it could be a nice, flashy university, but if the fit is wrong and if the environment is wrong and the way that we teach is wrong, then you are not going to succeed. So I would suggest to you that in addition to considering location and ranking, I would highly recommend you to deviate from the mainstream information being provided about that university through our official channels. What I am saying is don't look at our website. right? But go onto YouTube, go onto Instagram, go onto Reddit, and go and see what other people have said about UQ. That's what I would recommend, because we have many, many of our students that actually give you a glimpse of their lives while they're at our university, and maybe that might allow you to come to that decision a bit more in a bit more of an informed way. Okay. A question here about field and lab work, whether or not we ever collaborate with professional and official science organizations. That's a great question. So UQ is a research-intensive university, and there are 8 universities in Australia that are research-intensive universities. Collectively, we call ourselves the Group of 8, right? There are similar models in the US, for example, and in Canada, where conglomerates of universities are recognized for their research prestige. So we're one of those. We are a group of 8 university, and of course, the only one in the state of Queensland. Being a research-intensive university allows us to leverage the level of research that we do to host professional research institutions on campus. So the Australian Institute of Nanotechnology and Bioengineering is on our campus. Boeing has a presence on our campus. The Australian Infectious Diseases Institute is on our campus. The Queensland Agricultural Food and Innovation Alliance is on our campus. And then if you take a bus ride across the river, because we're at the edge of the river, just one stop down across the river are our collaborators from the government research organization. So that's what we call the CSIRO, the Commonwealth Scientific, I can never remember what the I is, research organization. And that's a large research entity, government entity that we have a lot of collaboration with. Now, having said that also, it really does depend on the discipline that you're doing, right? So our zoologists, for example, we do have collaborations with some of the wildlife sanctuaries and zoos across the state, right? Our marine biologists, for example, where we collaborate with a lot of the state level organizations that are funded to protect the Great Barrier Reef, but that's nowhere close to our campus, right? So there are a lot of sort of satellite hubs across the state of Queensland that UQ has a strong presence at, right? So absolutely, there are a good number, I would say. I mean, when it comes to teaching and research, I would say that about half of the students that do a research project do like fundamental pure research, whereas the others are doing applied research, oftentimes with an industry partner. Great. Okay, no questions currently, but I would really like to thank you all for joining us today. And we'll pop down our contact details into the chat very shortly if anyone is interested in reaching out. But I'm very, very thankful for your time today and hope you enjoy the rest of your evening. Grace is about to just put our contact details in case you needed to get in touch. That's science.international@uq.edu.au. Grace, I might have to change that to everyone. Thank you very much, Alexis. Okay, so thank you again, everyone, for joining us today. I hope you enjoy the rest of your evening. And yes, we'll hopefully the next time we get to see each other is here on campus at UQ. Thanks again and have a lovely day.